Hello students. Today we're going to be diving a little bit deeper into understanding models of waves and being able to actually use them properly. First, I just want to do a quick review of what we have covered. So you guys just finished a activity about what is amplitude, what does frequency mean, and most of you got it spot on, but you can see that as I change the amplitude, as the amplitude goes up, you can see that the waves get bigger. As amplitude goes down, the wave height goes down. So amplitude determines how big a wave is up and down, whereas frequency, you can see when I speed it up, it goes faster and then it goes down. You can see that it is going slower. There's less waves. So frequency is the amount of waves per second, or over a time period. It doesn't have to be second. So we started this by going over the sound. We were playing those annoying pitches. Well, at least some of you did, and I eventually couldn't hear it. So one of the questions at the end was, why does it make sense that volume of sound and amplitude are related? So if you're just thinking about volume, how loud something is, when I increase the amplitude, like it's going to be the same sound, it just looks bigger. So there's still like 3 waves here. And if we settle this, like you can still kind of see like 3 sections of the wave. And then to change the pitch, like to make it more annoying, like you can actually increase the frequency, and even that just looks more annoying. So you can get a visual representation that pitch, so the E versus O, is determined by frequency. So it'd be E, O, once you lower the amount of frequency, and you can see the wave calm down. So that was just a quick review of what we've done so far. Where we're heading next is, can you actually produce models of the waves given frequency or a graph of the wave? Can you describe a wave accurately? And the reason for doing this is, one, a little bit more appreciation of what do the waves in our lives actually mean. So for example, blue light, you'll see, has a frequency of 10 to the 15 hertz. What the heck does that mean? Well, this is what that number is, 10 to the 15th hertz. That's what blue light is. That's the color blue. Other things you'll see is things like 10 hertz, 20,000 hertz. You might hear something of a period of 2 seconds. All these things can be used to describe waves, and our goal is to be able to actually understand what that means. Can you interpret it in your head from what you see on the paper? All right, so that is the introduction part of this video session. Part 2 coming up next. Hey class, this is part 2 of the video, and this is going to be going over how do you actually take a wave, an actual picture of a wave, and find its period, frequency, and we're also going to be reviewing wavelength. So I'm going to go over how to do those things and also go over what those terms mean. So if we're taking a look at the screen up here, you'll see that frequency, so we've already discovered or talked about what that is, and there's a model here. So low frequency, medium frequency, high frequency is how many waves there are per second. Actually, frequency is how many waves there are over a given amount of time. The unit that we use for frequency is hertz. And that unit, so a hertz, is waves per second. Now, you're going to be asked to find the hertz. So how do we actually find that? And it's actually pretty simple. So the first thing is we need to know how long this takes. I'm going to keep it easy for us. So assume each wave has taken 1 second. So that was 1 second long. And we need the number of waves. So first thing we need to do is count up how many waves are here. So this is when you have to kind of review a wavelength. So it's from one wavelength is when the wave like starts to repeat itself. So in this case, we go from this top to this top would be one wave, because then it's about to repeat itself. So there's one, put a little one there, and then here's two. Now if we made it all the way up here, it'd be 3. So down here would be 2.5, and then we have about 2 and 3/4. Right, with the mouse is hard. All right, so we have, in other words, 2.75. This is why I put those lines in my 7s. That way you know that they're 7s. All right, so that's the number of waves. And if this took 1 second, and a hertz is how many waves per second, then we are left with 2.75 hertz. So because it's divided by 1, it's easy. I'll go over another example. So what about this wave? Now this one's a little bit different because it starts on this midsection. So to count the wave, we need to stop at every time it's about to head down, because it's starting going down. So the next time it's starting going down is going to be one wave. So there's 1, there's 2, there's 3, and if you kind of cut this in half, we have a half of a wave here. So 3.5. I'm just right over here. 3.5. So there's 3.5 waves here. That would give this 3.5 hertz. All right. Now I'm going to suggest that you guys actually pause the video, try to find the frequency here before I do it. So go ahead, take a little pause, see if you get the correct answer. All right, how do you actually find the frequency of this wave? So again, we're going to have to count how many waves there are. So I like to make marks for every time it repeats. So there's 1, 2, 3, 4, 5, 6, 7, and we didn't get all the way down to half, so this would be 7.25. So we have 7.25 waves per second, also known as 7.25 hertz. All right, so now we found the frequency. On that other section that I'm going to want you guys to do is also a different word, but related, which is the period. Now, to find the period of the wave, well, first let's start off with what a period is. So a period is how long it takes one complete wave cycle to occur. So how long does one complete wave take? So a down and up, or in this case it'd be like up and down. So this is actually the inverse of frequency. So frequency is waves per second. We want to know how many, a period, we want to know how many seconds per wave. So what's the time per wave? So this is actually just a little bit of math. You're going to take 1 divided by frequency. So in this case, we knew the frequency for the first one was 2.75 hertz. So the period would be 1 divided by 2.75, which equals 0.36. And on the calculator it says 0.363636. I'm okay with you rounding there. And so this is seconds. Yeah, this would be labeled in seconds. Seconds. So every 0.36 seconds is one wave, is what a period would mean. All right, so for our next one, so the medium we found was 3.5. So again, 1 divided by 3.5 hertz. And I should do this properly too. So now if we took 1 divided by 3.5, you're going to see that it's 0.285, so I'm going to round that to 2.9 seconds. So the period of this medium frequency is 0.29 seconds. And again, you guys could take a little break and try to figure out what is this period. So I'd suggest pause the video and try to figure it out. I'm just going to set it up. So you're going to take 1 divided by the frequency, which in this case is 7.25. So 1 divided by 7.25 hertz. And if we plug that baby in, 1 divided by 7.25, we're going to get 0.1, round. It's 1.37, so 0.137, so it's actually, that's a 4. Oh, it's a 4. So 0.14 second per wave. So it takes 0.14 seconds for that to occur. Another 0.14 seconds, another 1.4 seconds. So again, period is how long it takes for one wave to occur. All right, this was part 2 of the video. All right, students, this is part 3 of today's video sessions. And now we're going to be describing what these things mean when you see them in words. So you'll see that we're on the bottom side of that little practice sheet. And I'm just going to go over, say you see something like 10 hertz. What does that actually mean? 10 hertz means that there are 10 waves per second.
I'm going to do work here because I thought
We have a guest, Jackson Richter.
we had select choir, except we don't have select choir. And now I'm at school, and I'm not supposed to be at school. So I'm going to do homework.
Guest voice, Jackson Richter, for you. And now I wanted to go over what does 20,000 hertz mean. 20,000 hertz means that there are 20,000 waves per second. So you have 20,000 up and down movements every second.
That's a lot.
And then now, what does it mean for a period? Period of 2 seconds means that one wave takes 2 seconds to complete. That section should be pretty simple. This was round 3. Get ready for round 4.